So 2 videos ago, we created a sampler or looping station, something along those lines, inside of Plugdata, which is a free and open plugin you can use and patch your own solutions in there. So we created this, and if you haven't watched it, you can rewatch it. Link is in the description, of course. And this time we want to flesh it out. We want to add some features and almost turn it into some kind of plugin. So this is where we left off in the last video. We have one instrument channel here with the piano on there. We can play the piano. Then our patch samples the piano in here in this buffer and plays the buffer in reverse. So it's a nice audio effect. But it's not perfect. There's a lot of stuff we can tweak in here to make this even better. So the first thing we want to change is the sample rate. We use the sample rate here in this patch already with some fixed numbers. So we typed in here basically for the V line, please start at 96,000, which is the end of the array. And the array itself is also fixed here with 96,000 in size, right? So it's all fixed numbers. And all these numbers can change. So when you send this patch over to your friend, he uses a different sample rate, and nothing makes sense anymore. So we have to keep this dynamic. So instead of using here 96,000, we use a module called sample rate, which gives us the current sample rate of the DAW, of the host, as a number. In my case here, it's 48,000, right? So we get this number from this module here. And if you send this over to your friend, he uses a different sample rate, and this one gives back a different sample rate. So this is the idea behind it. Then we use a number here because we need to multiply the sample rate with the multiplication. Sample rate goes in here, this number goes in here. So now we can use basically the result of this for multiple places. In the first place we want to change this number is here the sampler itself, which is the array or the array buffer. And this one has a fixed size of 96,000, which is basically the sample rate times 2. Because we want to save 2 seconds of data. To change the size of the array, you have to use a module called send, or the shortcut, which is just S, and then the name of the array, which is sampler. You can see this here, right? So we can send something to the sampler or to the array. And in this case, we send a message. And the message contains a command, which is called resize. And instead of using a fixed number again, we use a variable $1. And we replace or exchange this $1 here with the input check. So the number from the multiplication here on top, right? So whatever comes out of this here gets replaced in this. Then we compile basically our command, and this command is sent over to the sampler. And then the sampler is resizing the buffer size basically. All we have to do now is to use here a bang, connect this here to the sample rate, then change here maybe this to 4, hit bang, and you can see we have a different size here. We go back to 1, you can see it's a different size. So we can change the sample or the buffer size basically based on this number, and this number represents the seconds of data or seconds of audio we want to record. So we can change this here and can say, I want to save 11 seconds of audio, right? And then you bang it, and then this buffer size changes to the right number based on the sample rate. Okay, we can now use the result of this operation here also for the V line. The V line creates some kind of phase signal to move the pointer from the end of the array to the beginning of the array. The beginning of the array is always 0, and the end of the array changes dependent on the sampling rate and also on the time frame. Also the time frame here is 2000 milliseconds, which also change when you change the length right here. So we have to make this also dynamic. So I'm using here a message, so I'm creating a new message here. And instead of typing in fixed numbers, I use $1. Then I use the beginning of the array, which is always 0. And then the time frame is $2. So we need to replace basically a $1 and $2. $1 is basically the result of this. So we could connect this, but we need also to connect here $2. And $2 is basically this number here multiplied by 1000 to get milliseconds instead of seconds. And then we need to use another module called pack, which packs up 2 floats as an input. So float 1, float 2. You can also use your, if you want to do more, you can use 3, of course. Then you have 3 input checks, right? That's how it works, but we only need 2. So we pack float 1 and float 2 into one signal and connect the signal with that. And then we can use, instead of this message, we can use this message, which is now dynamic. And instead of triggering this here via mouse click, we use here the output of this and trigger this all the time, right? So we get on each trigger, we get the right sampling rate. We get also here a different buffer size, right? This changes then here accordingly. Then we also have the right V-line or the phase signal from the right end position to the right start position in the right time frame, because we update everything here with each click. I hope this makes sense. So now, instead of using fixed numbers, we use dynamic numbers that can change from PC to PC and also dependent on the seconds for the buffer size. Another value we need to change is here the delay time of the fade out. Maybe you can remember we implemented here a fade in and a fade out of the audio signal to get rid of clicks and pops. And of course, this value is dependent on the sample rate, and it's also dependent on the buffer size, right? And how many seconds we want to record. So we can just get rid here of the number, of the fixed number, and we use here the input jack, and we just subtract 200 milliseconds from the milliseconds of the length of our buffer, which in this case here, when we go back to 2, right? 2 times 1000 is 2000. Then we subtract 200, which is then 1800. So we get our value here. So if you want to make the fade in and fade out time also dynamic, you also have to make this here dynamic, right? So you have to make these 3 values basically dynamic. But now we get correct fade in and fade out delays here. The fade in is always at the beginning, so you don't need to change something, but the fade out here happens at different points in time because the array size can change. So now we have this also dynamic, which is good. And because we can change the length of the buffer here with this number, maybe it's time to implement something like this knob here instead of using this number box. And this one has a minimum value of 0.1. And the maximum number is maybe 8 seconds, or maybe let's say 10 seconds. So we can change the buffer size here just with this nice interface knob. What we also have to change is here the metronome. As you can see, the metronome basically triggers or re-triggers the playback of this buffer every 2 seconds. But because we change here the size or the length of the buffer size with this, we also have to change the distance between the banks. So we use the output here of this as the input of that. And when we change here the number, you can see the metronome basically changes or re-triggers more often when the buffer is smaller, which is exactly what we want. So let's try this out. And the problem now is that the buffer is always with the next iteration completely empty. So in my opinion, there should be at least some kind of feedback line in there. And we can implement this pretty easy here. Maybe I move this here a bit to the side. Let's move it over here. So we use the output of the tab reader here and feed it back into the input with the tab reader. So we have a slowly decaying audio signal. So let's try this out. I probably need to use here multiplication, and we get here another knob, which is the feedback value. So maximum number is 1, maybe go to 0.9 or something like this. And then we use the output here of the tab reader and go back into the tab reader itself, right? So let's try this out here with some kind of feedback value. So it's almost like an echo, or it is actually an echo. In this case, the echo is playing everything in reverse, which I like. So now comes the interesting part. We have a lot of weird wires inside here, and we want to make this a bit more pleasing to the eyes. So the first thing I want to do is to go down here and use the small little eye symbol. And it implements here, or at least you can see here, some kind of dashed line in the background, right? And this is our, yeah, let's say plugin window. So let's move everything outside of this window, so we don't have anything in there. So what we can do now is to put everything in there we want to have to show to the user. The dry level here, the wet level, maybe the sampler buffer itself. Let's put it over here, make it a bit longer, something like this. Then we have here feedback, of course. Let's put this over there. Maybe more space between there. Let's put a comment in here. This is the feedback. What else? We have here the length of the sampler. Can put this over here. Length. Okay. So we can also right click here, properties, and then we can change the height and the width of this. Let's go for this and like that, maybe a bit more, something like this. So now you can use the plugin mode, so-called plugin mode. So you press on the right side at the top here, this is a small icon. You can say enter plugin mode, and now it looks like this. You can open it back up with this. Maybe disable here all the information boxes, and then go back into plugin mode. And then you have some kind of plugin, or at least it looks like a plugin, where you can change all the So it works and looks like a real plugin you would use. You can also save this now here as a preset and reload it, and you have it in the same, yeah, it looks like the same basically. Back in here, all these cables across the patch doesn't look that great. So what we can do about this is to use send and receive modules, which I like a lot. It works kind of like modulator outs in the grid. So you say, for instance, you send and call this sample length, for instance, right? This is some kind of ID you can use. You go into that, and then you say receive sample length, and you get the data you sent in here, you get out of this box or out of this output jack, right? So you can delete this here and go into there and can save some kind of wiring with that. Let's see, so we have also here the dry level. Send volume dry. Dry level goes in here, then receive dry, and you go in there. Now you can delete these two. So it becomes a bit more, you know, you can clean it up a bit more. This is vocal wet. Go in there. And this is receive. It's much more pleasing now, and it's, you know, in my opinion, it's cleaner. This is the feedback here. Let's keep it short. Yeah, nice. So it works exactly the same, but now you have basically all these interface modules decoupled from the rest of the patch, which is nice to have. You can also right click here on these cables and can say curved connection, then you get something like this. We can organize, you know, the wires a bit better. Maybe it's not that better, but you can do it at least. Okay, you can also use the output in here, of course. Send here, maybe this to here. Say send v-line receive v-line. Put this over here and delete that, so it's a bit cleaner. Nice. Let's look into plugin mode here. It looks still the same. Okay, nice. So there's one problem we have to tackle with this patch. And let's imagine you have your dialed in all the stuff. Everything works. You save this patch, close it, right click here on the container, say save preset to library, and then it says tutorial Plugdata sampler. You choose the category audio FX, right? You save it, and then you delete here the plugin and you recall it, and then, or let's actually go into plugin mode before. Right click, save, save. And now you reload it, and all the values in here, as you can see, dry level, wet level, feedback, length, and so on, everything is at 0. So there are no real initial values. Also, the sampler doesn't play or doesn't record at all. You have to go into the patch here, and you have to press playback here actually to start the sampler. So this is not really nice. So what we do with this is we use a module called load bang, and load bang only fires one bang every time you load the patch. So we can use this to actually start the playback. We can use this to create here a new message. Yeah, message. Let's say we use here 5. So 5 is the number we want to have for the length. For the beginning, this is a value between 0.1 and 10. So we use 5 here for the length, right? We can maybe also use, this is between 0 and 1. So we use here 0.3 maybe for the feedback, right? And the dry level here is, yeah, let's say also 0.5. Okay, so we go back here into plugin mode, or actually save the patch, plugin mode, save preset the library, and then we load here the sampler back in, and you can see we have now here nice initial values for everything. And also the sampler is already recording and playing. So that's kind of it for this video so far. Maybe I make a third video on this plugin or on this patch, and we implement even more features and make it more interesting. At the moment it's just a looper playing stuff backwards, so it's not really interesting. But I really enjoy actually tinkering around with Plugdata at the moment, getting out of the Bitwig world, getting out of all the plugins that, you know, coming out at the moment. I'm not really interested in that. It's kind of all the same stuff. So getting into Plugdata, tinkering around, learning something new, it's really interesting for me. I am enjoying it. So if you like the video, please like the video, of course. Subscribe to the channel. Ask me questions if you have one, or maybe if you find some errors in this video, let me know. Okay. The preset or the patch is in the description below. You can just download it, play around with it, have a go, and yeah, that's it. Thanks for watching the video. See you next time. Bye.